So let us look at the POSIX interface basically. And POSIX is a standard that was designed by the IEEE, one of the leading technical organizations in the world that basically manages almost everything related to engineering in many ways, especially I mean, both professionally and academically. So this is where, for example, academics publish conferences, publishing conferences that are run and organized by the IEEE. So there are a series of standards from the IEEE that basically define how a, li- a library, a programming library, should interact with the operating system. And you typically see that the POSIX defined API have a very strong, or APIs have a very strong correlation with what the system calls that are actually implemented in Linux are. And it's almost universally implemented for almost every single programming language you can think of. So you can see it for Python, for Java, for C, and basically you they implement the standard. So the standard is implemented. Actually, a language like Go, for example, implements the standard by just implementing this by just calling the system calls. So there are different design decisions that are related to using POSIX actually. Okay, and Linux system calls are accessed via function calls to the C library. That's the way you would do it in normal programs, and they are defined in the C library. I mean, you can actually go to this link, for example, C POSIX library, to look at that, and you can have arguments going into the syscall, and your system call can result in one or more side effects. And these side effects can be, for example, to allocate memory to some process, to open a file. I mean, these are sort of side effects. Writing to a file also. These are also such side effects. But there are some syscalls that do not have any side effects. For example, the getPID syscall that basically returns to you the process ID. It has no side effects, as in it does not change things on the system. It just gives you back a value. The return from any system call is always long. I mean, it's all system calls will have long as the return value. This is a rule of thumb. Okay, and getting a positive number usually signifies success. A negative return value would usually denote an error, but not always. I mean, it's a mess like everything in operating systems, basically. Do know that the Linux operating system has been maintained for over 20 years now, and things have changed, basically. And a lot of this is even inherited from Unix, which means that a lot of this is just, well, legacy. So usually, though not always, a negative return value would denote an error. Zero is usually a sign of success, but again, not always. Okay, so if you get an error, then you get an error. There is a variable that's called error no, so which is error number basically, and this is basically used by many functions to return error values. So if you get an error in your system call, that the error will be an error no, an error number. And you can actually use a function to translate that error, and that's, for example, p error. There's a function that is called p error, to which you pass the error that you get from system call, and then it will just tell you that, okay, this error corresponds to you have no access to this file, for example, or this file does not exist. Okay, so let's look at an example of system call definition. Syscall define 0 is a macro. Syscall define is the macro that defines how system calls are implemented. And if and the number over here, the number at the end signifies how many parameters are going to be passed to this system call. How many parameters does this syscall return? Okay, so get PID, for example, is defined here as a system call that gets as input 0 inputs and returns the current tasks. The current tasks thread TGID, which is basically the thread group ID. And we haven't really talked about the thread group ID, but if you have just processes, normal processes, the tgid is equal to the normal PID. So if you have just processes, then this is, well, if you're not doing multi-processing or multi-threading, then your tgid is basically your application ID, your PID. With threads, it gets a bit different because you get, this is the thread group ID, which basically signifies that these threads fall within the same group, i.e., they share the same parent, for example, okay, or they share the same grandparent. You set it based on what thread groups, okay. This enables basically a thread to call get PID and get the same PID. So all of the threads will call, if all of the threads in the thread group calls the get PID, they would get their thread group ID, knowing that, okay, this is sort of our group. Okay, you can get the per thread PID also. That is also implemented, but this is what get PID does. Okay.